All right, let's see if we can't do a latency check. What's the delay looking like today? How are you doing today? All right, and I'm going to time that and see when I get your response. All right, so we've got about a 3-4 second latency. That is a-okay. We could work with that. Last time it was about 15 seconds, which is a little much. It's like talking to the moon mission. Now, of course, I'm actually doing something important and not just landing on the moon, so a little bit different. And so next week, we're looking forward. It looks like I don't know what actually the Earth to the Moon distance is in seconds. I guess that varies based on the orbital eccentricity. I might have to ask that to Wolfram Alpha. Is that really just 1.3 light seconds? That's nothing at all. All right. So today, what we're going to be talking about is some great plotting with ggplot. All right, and we're going to do a general overview of ggplot, which a lot of you have already seen with me. So I don't want to make it just a rehash of that. There'll be a little bit of reoccurring material. We'll also look at some different options with ggplot, some things you can do, some additional packages on top of ggplot, which give you more control over things or less control for good reason, and some just general plotting guidelines. And so as I go through this talk, I'm going to be sharing essentially my opinion on a number of things, and you shouldn't treat this as gospel, all right? You should treat this as, all right, here's what Dr. Lerin thinks about this, and I'm going to create my own impression when I deal with these things, right? So take this as sort of informed advice, but not, the word of the plotting lords or anything like that. Because there are, hundreds of thousands of engineers in this country. So just because I say something looks good and you want to do it that way doesn't mean that your boss or your colleagues will agree with me. They might not like anything I do, in which case you'll have to adjust. But I'm going to give you my informed opinion. We'll talk about some options that you've got in terms of your plotting softwares that are all based on the ggplot paradigm, and what we can do with those. All right, and I'm going to start with essentially telling you that nobody is going to read what you write. No one will read your text. Right? That's not actually true, but it's something to keep in mind. It's one of those truths that's not really true, but is a good sort of design paradigm when you write a document or a report or a research paper. Right? Because figures and data are the real meat of your report, of your research work. Right? If they wanted to read somebody's opinion on something, they could read a blog post, they could read, an op-ed on something, and they could then just, oh, there's someone's opinion on that. But what makes your opinion worthwhile, which makes your conclusions valuable, is the fact that you've got data that you've collected and analyzed, and you had some response. You had some conclusion from that. So figures and data are the meat of any research or technical report. Everything else is just potpourri. It's just, window dressing. Or essentially a recipe for how you got the figures and the data. All right? And everybody's busy, right? I'm busy, you're busy, everybody's way too busy. So when they get a research paper or a technical report, they're not going to pour through every little piece of it to go over exactly what you did and what you found. All right? So I've given you here essentially a list of the priority of reading something, and every time you move from one level to the next, you lose about half of your audience. All right? So everybody who encounters your paper will see the title of it. So 100% of people who encounter your paper or your report will see its title. About half of people will ignore it after they see the title. They say, this title is not what I want. I'm not interested in this problem that's being solved. I don't really care. Right? The other half will move on to your abstract. Right? And they'll say, oh, well, this title seems interesting. What's going on in the abstract? And they'll read the abstract, and about half the time, about half of them will say, okay, that's not as relevant as I thought, and they'll stop. And the other half will move on. What they'll move on to is not the text, not the introduction, not the conclusion. They'll move on to the figures. They'll say, is this data like the data I have? Are these analyses like the analyses I want to do? Do these address the same research questions? All right, so you're already at about 25% of people moving on to your figures. And I'm just making these numbers up. These are just guidelines. All right, so about 25% of people will see your figures. And so you really want your figures to tell the oomph of the story. You want your figures to be packed with information and able to be self-contained and tell the story you want to tell. All right, and after they read the figures, if they don't understand them or they want more information, they'll read the captions. So you've got about an eighth, 12%. Reading your captions. And finally, about 1/16, 6% will actually go through and read your recipes, your introduction, your methodology sections, your mathematical equations, your summary, your analysis, your conclusions, your discussion. Right? So if you're relying on your text to tell the story of your research paper, of your report, you're going to be getting to a much lower audience, right? Using those rule of thumbs there. We're talking like 6% here. Let me I went and found a program that lets me draw, versus about 25% here. Right? So keep that in mind, that you want your figures to give you the oomph, because that's what the people read. And this is essentially what I was told in grad school, and now I'm telling you, this is how the world works. Maybe everybody reads the reports. I don't think so. We can't even get the president to read his national security briefings unless they have. Anybody hear what they had to do to the national security briefings to make him actually read them, or get the information? They had to put pictures. They had to put figures in there. And it's just the same. We all have the attention span of the president in some regard. So you want to contain, to share that information in figures, and that's just fine because figures contain huge amounts of information on a single, image. All right. So if we want our figures to be good, to actually contain the oomph of our research paper or our technical report, we need to follow some guidelines on those. And the first design consideration I'm going to tell you, the most important one, it's at the bottom here, but it's because it's the takeaway, is every graph should be designed to tell a story or answer a specific question. Don't have a graph that doesn't say anything, because someone will look for meaning in that graph. They will assume this graph, there's a purpose to this graph, there's a reason it's here, I need to find the story in this graph. If they can't find it, they will be confused. They don't know that there isn't one. All right? So that's the moral of every figure, every picture, every diagram. It should be designed to tell a story about your research or answer a specific question, a research question. All right? In order to achieve that, what we can do is we can make every graph clearly titled and labeled. Right? And we need to include our units as well. It doesn't do any good to say that distance is on one of my axes, because distance as measured in what? Light years are a lot different than centimeters. So you need your units there as well. And then another key component is graphs need to be self-contained. Like I said, people aren't going to go into your text. You're going to lose people. If they have to go to your text to understand your figure, they're not going to understand their figure. They're going to make the choice of going somewhere else, some other paper. So if you can make your graph self-contained and tell the full story between the graph and the caption, then you'll be able to transmit the information to a wider audience, and your publication count will go up, and your boss will actually understand your reports, and things like that. All right? Your label should be as informative as possible, right? You just don't want to say distance. You want to say distance from, or distance as measured by, or distance, you want to give essentially a description of, what it is and how it was measured, if you can, if you've got room for that. And finally, kind of contrasting with being as informative as possible, they also should be uncluttered. You don't want to make a graph label on an X or a Y axis be a paragraph, right? Because people won't read that. There's a constant struggle between trying to get information without having to do any work. And your graph making, your figure making guideline should reflect that every time I include more information in here, if I don't do it carefully, I will make less people read it because I will make the graph more cluttered and hard to understand. So there's that constant push and pull of, I want to include as much information as possible, but also make it as readable and understandable as possible. And that is why we're going to look at some very nice plotting libraries that will allow us to do that. Right? They're optimized to give us that power. All right, so we're going to talk essentially about 3 different packages for making great plots in R, which is the sort of paradigm we're using, because that's what I've taught in my statistics courses. That's not the only way I make plots. It's context dependent. We'll talk about that in a second. But we've got essentially 3 main packages with 4 options total for making these nice plots. Right? And the first one is GGPLOT, and that's the heavy hitter, right? That's the Schrodinger equation of modeling the universe, right? You're making no assumptions, you're maintaining total control, you can do anything you want accurately. It's so custom tunable that you can do anything, right? And then there's one level of abstraction on top of that, which is called QPLOT within GGPLOT. And QPLOT is the GGPLOT version of what's called a quick plot. It's like, I want to give up some control, I want to give up some customizability to make it quick. And so you lose a little bit of control, but you make it faster. All right, and then there's another level of abstraction on top of that called GGPubR, right? And that takes away a lot of the control from you by supplying a lot of very useful and pretty defaults. GGPubR stands for GGPLOT publication ready, right? So the paradigm of GGPubR was they don't want you fiddling around with all the options in GGPLOT for 3 hours, right? To make it good enough for your boss or good enough for the research journal, right? So they said, you know what? Well, we'll write a lot of macros which handles everything and makes it look nice enough to go to a research journal or something without having to spend all that time customizing it. And then finally, within a very specific research paradigm, which may be useful to you as an engineer, we've got GGQC, which GGQC is quality control, GGPLOT quality control graphs, right? And that takes away a lot of your tools in GGPLOT and writes macros over them to give you standardized quality control plots. And so we're going to be looking at these essentially 3 packages and 4 different ways of making plots. Right? But that is not the only way of making plots. So I want to essentially talk about the plotting environment right now, as far as I know it and am aware of it. Right? And my one big statement to you is avoid being the Excel person. Don't be going and giving research talks or conference presentations or technical reports in Excel. And that's not because Excel is bad. Excel is great. Right? Excel has a lot of use cases that are perfect. I have a monthly budget that I write in Excel. I like that more than like Mint or any of these automated programs because it gives me more involvement and I feel more invested in my money. So Excel is great for a lot of things. All right? And you can actually use Excel to make decent looking plots. I'm not saying every plot made in Excel turns out ugly as sin. A lot of them do by default. Out of the box, they do look ugly as sin. But Excel graphs can actually be made to look decent. The issue with Excel is essentially it shows your level of sophistication in doing analyses, right? If you do a graph in Excel, the assumption by the people reading your graphs, looking at your graphs, are this person did the analysis in Excel. This person doesn't know how to use R or MATLAB or Python, NumPy. This person is not a sophisticated programmer in those environments, right? They can't get it done, so they need a GUI to help them out. Now, is that necessarily true? No. That's a faulty assumption, but it's the assumption that you might be putting out there, right? Because if you did all your analysis in R or Matplot or Python or MATLAB, you would probably just plot it in MATLAB or Python or R, right? And so Excel is fine for a lot of things, but in terms of statistical analyses, it's not terribly sophisticated. So the assumption you're giving when you give an Excel talk and an Excel plot is that your analysis is not sophisticated. Right, and that's exactly right. Excel is what you're taught in middle school. And so if you want to essentially show the people that you have not gained any level of plotting sophistication since middle school, go ahead and use the Excel plot. Right, but there are loaded assumptions with that. I like to think of Excel plotting as instant coffee, right? Instant coffee can taste good, right? There are some good instant coffees out there, and it's super fast and easy, but it's not sophisticated. So you're not giving yourself the image of a coffee connoisseur or an aficionado if you're making instant coffee. You're not giving yourself the view of you're not giving the impression of a sophisticated data analyzer if you using Excel. So just keep that in mind. Excel is fine. I will make quick plots in Excel if I just need a super quick plot in data that I already have in a spreadsheet. But I wouldn't give talks in it, right? And that's purely a subjective thing. It's not, the smartest person in the room can make a plot in Excel just because that's what they want to do. This is sort of a cultural stigma that should not exist but does. And I'm just making you aware of it. So I'm going to give you my purely subjective rank in plotting tools, right? In terms of how they look and how sophisticated they give you the image of, how they depict you. All right, so the S tier are 3 options, 2 of which are in R, and 1 of which is outside of R, right? So the 2 options in R are GGPLOT2 and GGPubR, which is the publication-ready package on top of GGPLOT2. That's giving you the best looking, most customizable, most powerful plots in the R environment. But if you're not in R, Matplotlib and the Plotly libraries associated with it can make graphs that look just as good. Totally fine. Right? I did my dissertation graphs mostly in Matplotlib. I brought my data over from MATLAB and Fortran codes into Python to analyze using Matplotlib. Right? And that's interesting because I did my analysis in MATLAB, but I didn't do the plotting in MATLAB. Right? And the reason for that is I consider MATLAB's updated plotting libraries and updated plotting routines more of an A tier. Right? They actually make calls to Matplotlib and Plotly commands, but the interface and the defaults in the updated MATLAB libraries, updated as in since 2014, which sort of shows you how long I've been in the environment of plotting in MATLAB, is, they have decent looking plots in the updated MATLAB. But I'd still like Matplotlib quite a bit better. Things look more crisp and clean and customizable, and it's more easy to understand in the Python Matplotlib environment. So that's the S tier. If you're in R doing statistics, GGPLOT2, GGPubR. Yes, absolutely. If you're doing an analysis of text data or data that you have from somewhere else that you don't want to read into R because it's not formatted like R likes, go ahead and use Matplotlib. It's a bit more friendly on vectors and stuff than R. R is not a matrix or vector language, really. But if you just need a quick plot for internal consumption and you're doing your stuff in MATLAB, MATLAB's plotting libraries are fine. Right? I can't think of anything in the B tier. Right? Maybe some programs like JASP and SPSS, but those are in a whole different realm of you don't have, they make nice looking plots, but they're not customizable. You don't have a lot of control over them. Then in the C tier, we've got R-based plotting, using R to plot things without any. It is kind of funny in that way, but Matplotlib is a lot prettier, I would say, than MATLAB's old plotting library. MATLAB's old plotting library gave you ugly graphs with ugly gray backgrounds and ugly figure settings and ugly legend settings, and you really had to fight with it to make a pretty looking plot. And the same thing is true in R-based plotting, right? It gives you this ugly raster image with no ability to typeset LaTeX commands in the figures or anything like that, and it's just it's like wrangling cats or herding cats and trying to make a nice looking plot. And the base plotting thing, or if you've got an old version of MATLAB, or if you're using Octave because you hate your life, but like free software, right? That's exactly what I mean. A lot more lines of code making a MATLAB plot look good compared to our other options. And then finally, we've got Excel, which it takes a lot of work that isn't even work in terms of code. It's an irreproducible set of GUI clicks to make your things look good and fiddle around with. And you've got all that stigma we talked about. So we're really going to focus in this talk on the two S-tier options that are in R, because I teach all my stats classes in R. If I ever teach a numerical analysis class, I will also expect you to use MATLAB. I'll teach that in MATLAB, and so we'll also talk about plotting libraries in there after I do that. But I haven't written the slides and stuff for that. I've just learned it myself, so we're not talking about that one today. But it is a fine option if you feel like using it. So first, we're going to talk about the ultimate weapon, the tool that will always work if you're willing to make the sacrifices that go into it, GGPLOT. And GGPLOT2. All right, GGPLOT. The GG stands for Grammar of Graphics. Right, and it's not even GGPLOT2 wasn't a data library first. There was a grammar of graphics. There was a paradigm for putting plot elements onto a plot that preceded the implementation of the library. So Grammar of Graphics is a sort of unified paradigm of thinking about graphical depictions of data, right? And the ggplot library is written in that paradigm. And it gives you a unified syntax for creating and manipulating graphical attributes of plots, right? And there are three key components to ggplot graphs in ggplot2. Right? And our three key components are the canvas that we're doing this on, and that has its own sort of syntax to create. The layers we put on that graph, and we can add as many layers as we like, and then the aesthetics. Right? And those are the key components. There are other components like adding your labels and your units and your titles and your limits and stuff like that. But those are all, window dressing. You need them to make it look nice and make it ready for publication, but they're not the fundamentals of the ggplot library. All right, so the first thing you can do, and I honestly kind of made a mistake here, and I assume everybody has ggplot because most of you are all my students. But if you do not have ggplot in R, all you need to do is essentially go to R Studio and say, you can ask if I have that library. And so you do library ggplot2, and I've got it. And so it lets me have it. If it gives you an error, you can just do install.packages ggplot2. And that will give you your code to run to install ggplot. And I'll just go ahead and put these in here. I don't know if this is going to work. It works in Zoom, so we'll try it in the YouTube chat as well. But I'll be dropping the code depicted in my slides, or that we do together, into the chat for you to run. And that's probably against the terms of service because I might be doing SQL injections or whatnot, but it's probably fine. All right, so that's how you can get ggplot up and running on your environment. All right, so once you've decided I have a data set that I want to plot, the way you associate that data set with a plot is by using the ggplot command. right? And you say, I want to set up a blank canvas associated with a certain data set. So I'm going to be plotting variables within this data set, right? And so when you say P1 equals ggplot MT cars, you're saying, give me a blank canvas that is going to be plotting attributes of the MT cars data set, this data set, MT cars, which is built into R, and save it as plot1. We call that the plot handle, the figure handle. So every time you want to do something to plot1, like save it or delete it or add a new layer to it or make it bigger or smaller, you just talk about that handle, plot1. We call plot1 the figure handle, like in MATLAB. And so we see here, once you look at that canvas after we've associated with the MT cars data set, this is the picture of the plot at this point. It is literally just a blank canvas, right? Because if we actually want to start seeing things on it, we need to turn to our other graphical attributes, our layers and our aesthetics. And so I'll give you this. You can also just type it in, but the advantage of doing, that's not formatting it quite nicely, but the advantage of doing the slides in R is that the code is in plain text and it actually runs inside the slides, which is pretty neat. But, I'm live streaming this. All right. So the second thing you need to figure out is once you've got your data set and your layer, you need to sort out your aesthetic. Right? And we use the AES function for that in the grammar of graphics paradigm, which controls what's called the aesthetic mappings. It tells you what variable controls the x-axis, what variable controls the position on the y-axis, which variable controls the color or size of your graphical elements. Right? So that will either go inside your individual layers, once you create them, or inside your canvas call. If you put it in your canvas, in your ggplot command, every layer will have the same aesthetic mapping. Every layer will map the same attribute to the y-axis, the same attribute to the x-axis, the same attribute to color, fill, shape, all of your different graphical elements that appear there. All right? And so you can think of these aesthetics as, the coordinates and the different attributes. You're mapping variables to them. You're saying, I want the fuel economy to be on the x-axis. I want the weight to be on the y-axis. I want this to go there, and so on. All right? And so we can update our plot, our canvas, and say, give me the canvas with MT cars, but also map certain variables like the car's weight and the car's fuel economy to certain aesthetics. Don't give me any layers yet. Just map those variables to the aesthetics. And you see something different than the regular blank canvas if you set up your canvas call that way. What do we see compared to the previous canvas? We see that certain variables are now associated with certain elements, with certain aesthetics. When we said X was going to be the weight of the car, sure enough, we now have a Cartesian coordinate associated with weight and values associated with that. When we said Y was going to be the fuel economy, we have that fuel economy on the y-axis, and we see the values, the range those values take on. When I say color, which is COL, is some other thing, it doesn't appear until I add the layers. So now we have a canvas with aesthetics mapped to it. And from there, we can start adding graphical layers. All right, once you've got your aesthetic defined, you can start adding those geometric graphical elements. Right? Lines, bars, boxes, points, jitter plots, bars, anything. Right? Trend lines, all of those graphical elements can then be plotted on there. All right? So when we take those aesthetic mappings and put them in the ggplot command, we can then just append different layers, one after the other after the other. So I just say, give me a point plot of those layers, give me a line plot, give me a point plot of those aesthetics, give me a line plot of those aesthetics, give me a trend line with a linear model, map to those aesthetics. And so when we do that, I don't know why that didn't depict it, but we'll just run it right here. Come on. When we do that, we see the plots, and we see all of those graphical elements shown in the plot. Right? And that example, that's not a good example I just gave you. It's way too cluttered. But the reason I gave you that example is you can see the adding of all of those different geometrical elements. When I say give me a geometrical point element, geom point, it gives me the points. With the X position determined by the weight of the car, the Y position determined by the fuel economy of the car, and the color determined by the number of cylinders, as mapped by my aesthetic. X is weight, Y is fuel economy, color is the number of cylinders. All right? And there are about 24 different geometric elements that you have options to add, and another dozen or so statistical elements that give you derived quantities. All right, and I have a link at the end of this that I will send you, and I guess I can send it just now. There is a GGPLOT2 cheat sheet that has all of the information on all of those elements. And so what do you mean by higher dimensional mapping? You can get more than just 2 attributes, yes. All right, but you usually view those 3rd and 4th and 5th dimensional ones as color or shape or transparency or all of your different aesthetics. All right, and so if we go to the aesthetic part of this cheat sheet, it's around here somewhere. The aesthetic mapping. Right, here's the aesthetics to adjust. Oh, nope, it's at the front. There we go. Right, they talk about all your different aesthetics that you can map to. They give you the paradigm and your different aesthetics. X, Y, Z, whatever, and you can see the different sort of options you have for that. And they give you sort of recommendations. If you have a single continuous variable, you just have an X aesthetic usually if you just want to plot the distribution of the thing. All right, but if you have more, if you have like 3-dimensional data, you'll generally go to some sort of color plot, pseudo color, or let's scroll down a little bit. Things are a bit slow that I'm streaming. I'm fighting with it. Right, if you got these 3 variables, you've got contour plots, raster plots, which is a pseudo color plot in MATLAB, tile plots, and so on. Right, and these map X, Y's, and Z's. Unfortunately, GGPLOT2 in its base library doesn't allow for X, Y, Z type scatter plots or sort of 3D visualization of data. Right, that's just not what it was designed to do. It's not a 3D data rendering sort of environment. There are platforms in R for that. I do not use them because I find you can't put a 3D manipulatable image in a plot, in a paper, right? Generally, if I want a 3D manipulatable widget, I will, really try to talk myself out of needing that. And if I can't, I will turn to something like Mathematica. Because I don't view those even as plots. I view those as a fundamentally different operation, and so I will fire up Mathematica and give myself a 3D widget. All right, but there are packages. If you do 3D plotting in R, there are packages for that. Not recommended. I'm not going to recommend them for you, but they're out there. Python has Mayawi, and I've used that a few times, and it's kind of awesome, but I never learned it. The things I was able to do were cool. And so you can do, like, here we have a scatter 3D, and like, look, what does this look like? If I wanted this plot, what would I do? Would I learn this plotting package? No, that could make that exact same plot in MATLAB with just a plot3D command. So, you know, I view these as being my issue with 3D plots like this is, what do you think? How do you think that goes along my paradigms for plotting good plotting guidelines? You were asking yourself to violate the last rule here. Graphs should be uncluttered, because trying to depict a two-dimensional or a three-dimensional object in a two-dimensional projection of an image, highly cluttered, it's a nightmare, right? Now, as we move into the future, when you're going to actually have these holographic projections or your augmented reality kind of things, that will change, and I'm sure I'll be the old fogey railing against it 15 years from now, saying, back in my day, we just looked at pictures. But I think you can get away from that. My guidelines now, you can sort of put those in the context as being the old way of looking at things. And so we have all these different layers here, and if you want three-dimensional XYZ dimensional things, you've got your three variable options here. So here are all your graphical elements. You've got it. You can make any plot you want. It's great. Right? Now, the issue with using ggplot for that is it involves a lot of, the commands can get pretty hairy, like this one right here. This is an example of a plot. And it's not terrible, but it's like 5 to 8 different functions. It gives you a lot of control and customizability, but it's a bit overwhelming at the very beginning. So if you just need a plot quickly in the ggplot paradigm, there's the qplot command. All right, this is if you don't want to faff about with complicated layering strategies in ggplot. You can just look at the quick templates available to you and plot that. Right? These have the options of not including that complicated ggplot grammar or graphics paradigm, but it gives you the same type plot, and it gives you a little bit of customizability over it. It has a lot of useful default set. So we just call that qplot, and then you map your aesthetics manually. X equals, Y equals, color equals, Z equals, whatever. Say what geoms you want. Do I want a geometric bar plot, a box plot, a scatter plot, a linear regression, what have you? The same names they have in the complicated paradigm without having to include it as a different layer. And then your X limits and your Y limits and any labels like that. All right, so I can, instead of having to do a bunch of different layers, I could just do qplot, X equals weight, Y equals MPG, the data set is mtcars, and then add these geometric attributes. Give me a point plot of the X with an X value via the weight, the Y value being the fuel economy, and then give me a smooth sort of plot on that, right? Which gives you a sort of locally estimated polynomial function, a spline, if you will. Right? And there aren't any layers to this, are there? So this is nice if you just want something quick. And it works for essentially any of the geometric things here. It'll work for any of these. You just do quick plot and say, give me a line, give me a hex, give me a point, give me a quantile, give me a rug, give me a smooth, give me a text. And you can add more than one of those. Like here I said, give me a point, a smooth, and a smooth. But we could take that exact same thing, and I'll give this to you guys. And we can say, you know, I also want in here a geometric rug. Give me that geometric attribute as well. And it gives you the rug. It gives you these little ticks where the data points are. Right? And if you want a color, you don't have to use it within that aesthetic command. You just say color equals, you know, and we'll do mes.factor cylinder. And we get that. So this has the same options as a regular ggplot environment, but it's a no-holds-bar, free-for-all just shotgunning the information at it, right? You can do it in any order. You can say, I want the geometrical layers first, and then do the X, the Y, the Z. It doesn't have that same nice grammatical structure as a ggplot, but because the geometric structure of ggplot is so complicated, sometimes that's an advantage. All right, so that's quickplot in the ggplot environment. All right, and then I'm not going to call too much attention to it because this is sort of secondary stuff, but there are all the other sort of attributes on this cheat sheet that talk about things like adding labels, adding a title, adding, changing your limits to these things. All of these are documented in here, right? And it takes a little bit of time to find, but what I've just done is I have printed this off as a A3 picture and put it on my wall in the office, which I can no longer use. So eventually, if you use this enough and you make enough plots of this, it'll just be second nature to, here's how I control the limits, right? The limits, I know what I'm looking for. It's a star that's cut off. I think that's down at the bottom here, yeah. You can control your limits like this. All sorts of different options on here. And there's also a section in the axes. Where's the axes box on limits? Axes, it's labeled axes, faceting, graphical primitives, one variable. There's an axis box. We almost need you can find it later. All right, you also have statistical summary documents. These layers involve transformations of the data. They don't just plot the data, they involve looking at it binned, or it summarized, or a density of it, or anything like that. If you want to plot the mean or something, you have these statistical layers. Right, and so that's the ggplot environment. GGPLOT2, and it's very powerful and I like it a lot. Now, this plot looks pretty decent, right? It's not like an ugly MATLAB plot. It's got a nice color palette to it. It's got graphical elements. It's a bit cluttered, but we can essentially change that by getting rid of, say, that smooth layer. Don't need to deal with that. But would you say this plot is ready for publication? Could I just send this guy off to a research journal or put it in a report? Not really. You still need to play around with it a bit. Change the labels and stuff, probably adjust your limits and stuff. Play around with it some, right? And so you can do that in ggplot2 and you'll get the exact figure you want, but it will take a while. And so there's an alternative paradigm within R built on top of the ggplot package called ggpubr, which is publication-ready plots. All right? And this addresses two key limitations to ggplot2. One, it has all the defaults set up such that you can almost, as soon as you're done with the plot and mapping its aesthetics, send it off to some research journal and put it in your paper. It's publication-ready, is what they say. All right? And two, and this is the more important of the limitations of ggplot2 that it solves, is it automatically handles your statistical summary statistics and derived quantities and error bars. Right? If I want to plot an error bar in ggplot2, what I have to do by hand is code up essentially how wide the error bars should be, where they should start, where they should stop, where they should be centered. I need to find those quantities myself, put them in a data set, and then map the error bar geometric point onto the geometric attribute right here onto those aesthetics. Right? I have to actually find what the standard error of the mean is by hand using some function. I have to actually find out where the mean is by hand for some function and plot it there. That can be a pain. If you Google how to do that, you'll get a lot of tidyverse stuff using summarize functions and using anonymous function handles using, different attributes. You're not going to have any idea what's going on in the background, which is suboptimal, right? So as an alternative to that, ggplbar will do that for you. Right? And so you can get ggplbar by just doing install.packages, ggplbar, and then library, ggplbar. And that will give you an awesome way of essentially coming up with a way of plotting these derived quantities and making publication plots ready. Publication ready plots. All right? And so the logic of ggpub is a lot less consistent and rigidly defined than ggplot2's ggplot commands. It looks a lot more like a qplot. It's just a shotgun of different options in a GG histogram or a GG scatter plot or a GG whatever. And so what you just say is, I want this data set, I want this aesthetic to be that, I want this aesthetic to be that, and I want my color palette, I want these options, and I want to add certain derived quantities. I want to add a mean to that. Right? So it's just a scattergun of different options in a single line, a single function. And when you do that, you get this, where you have the histograms of these things, you have the means depicted, you've got your color palette added, and you've got default handling of transparency and stuff. Is this a pretty good looking graph? Just out of the box, compared to a histogram in base R or a histogram in even ggplot2. I'd swipe right on this plot. This is a good looking plot. I did it in the Coog colors just for fun. Why not? Right. This is publication ready almost. Right. I would still change the labels and give it a title, but apart from that, you have the derived information immediately plotted on there. If I want to add a mean to a ggplot, if I want to add a dotted mean line to a ggplot command using the base ggplot libraries, I have to go and identify essentially a layer that will allow me to plot a single line vertically up. And that layer is simple. It's just vline. But I have to go and find that layer and add that layer. I don't even see it on here. Vline. Yeah. So, yeah, it's not even on the cheat sheet. But you would have to know that. You have to know that geom vline would give you a vertical line, or geom hline gives you a horizontal line for those means. Whereas in the publication-ready pub-r framework, you just say, add the mean, and it knows what you want. Right? And it does it for each group based on the aesthetic you give it. So if you wanted the mean of all the things, that would be a little tricky. Right? Because you don't have that fine-tuned control like you do in a ggplot sort of framework. You could do that in ggplot by just finding the mean of all the things and just plotting a vertical line at the mean of all three groups together. But this one separates it out based on the aesthetic. So these are nice if you need something quick that looks good. Right? It's the visual equivalent of if you've got stuff all over your floor, just shoving it into the closet. These are also great for adding standard errors of the mean or confidence intervals or anything like that. Instead of actually having to do a ton of work by hand to get those confidence intervals, you just tell GG, you say add confidence interval, or add mean SEM, right? And it will give you that when you just say add. And I thought I had the code here. Let me just fire up my thing. I have I write my slides in R, so the code's right here. I didn't have the echo equals true. Now it'll show up when I recompile it, but that's all right. We have the code right here. I don't think I copied it. Oh, alas. It's not even in recent files. Goodness. Never try to do anything live because it'll just break. Now I've got it. Now we'll grab it. And you can actually run this in here. That's the nice thing about doing your things in R. We might have to do a talk on R Markdown, because you can actually get your plot in line with some text, and that's pretty neat. But that's neither here nor there. All right, so we've got this code, and you can see here that that one's plotting the median and the IQR. That's what this is. It plots up to the median, and then it adds the IQR as the error bars, and it also adds a jitter plot, which is a scatter plot kind of offset to give it some width. All right, but if I wanted the mean and the standard error of the mean, remember what we talked about, sigma x bar. Actually, I think it's mean just SE. There's your error bars for the mean and the standard error of the mean. If you wanted the mean and the confidence interval, you would just add mean CI. And if we get rid of the jitter plot, you'll see that we don't have the points anymore. And so there's your 95% confidence interval. And you can change what confidence interval you use. Doing that in the ggplot framework, using the ggplot syntax, is a huge pain. Using ggpub and the different GG options, GG histogram, GG scatterplot, GG box plots, those are the ggpub options. So if you see plots made on the internet, that's what they're using. And that lets you plot these derived quantities in a much easier fashion. And once again, you have all the options you can change, those shotgun options. Here I removed the color palette. We got a different color palette, whatever. You can define the color palette via the hex codes, and it will just do it in that order. So if we go back to the hex code versions of this, you can just say palette equals your list of hex codes. Then we can do fill as well. Fill is the same thing. The color aesthetic is the outside of the thing. The fill is the inside. So we add a fill aesthetic. Just changing that option. And get some nice cougar pride going. Now, of course, the issue with that is if you fill those things in, your error bars are harder to do. So then you might add an alpha equals 0.5 option. And now you've got transparency. Just shotgun or whatever you want to do to this thing. And you can iterate very quickly and get a nice looking graph. So it's nice. All right, so there's how to do derived quantities. All right, so we can also do, and this is a specific thing for engineers. I didn't know how to do this until 2 years ago to teach it. We can look at process control charts, and you could see how you could do this in GGPLOT2, right? You could add a line plot based on the sample, and map the x to the sample number, map the y to the the mean of the thing, then do your add a point layer, add a line layer, and then add some horizontal lines via the H-line layer to give you your upper confidence and lower confidence levels. Right? But that would involve 1, 2, 3, 4, 5, 6, 7, 8 layers. Which, sure, if you want to do that, have a ball, have a blast, but you don't need to put yourself through that. GGQC will do that for you. All right, install that packages GGQC for quality control and process control charts, and then just read your library activate your library for use. And once again, you kind of need to separate out these commands. I think a semicolon will do it, but I'm not positive because I can't use a fake enter I can't do a line break in the chat. All right, so we can make some data up, and I will make this talk available to anyone who sends me an email asking for it. That way you can work through these examples yourself. All right, so we can make some data up here, and this is just something I stole from the internet because that's what you do when you're trying to make examples. All right, and you just make up a process control environment. You make a bunch of samples of candle widths that you're making. You're manufacturing candles. You randomly generate them using your R norm commands that you learned with me in Stat 370 and your R unif, your random uniform commands. You just make up fake data and play around with it. Right? Then you can just add quality control layers and label layers to that. Right? And the nice thing about this is this is a package built on top of the GGPLOT2 library. So you can add any graphical layers you want to this. Right? The StatQC and the StatQC labels adds the quality control plot along with the upper confidence level, the lower confidence level, and the mean trend line. That's what the QC does. For these actual means, that's the thick plots, the thick points here, with the lines connecting them. And it adds the red lines for the upper and lower confidence level and the mean level. And then StatQC labels adds the labels to each one for the actual values, and you can play around with some options on there. But you can also add any ggplot element on top of this as you like. Right? You can use the same label commands. You can use, I've just put a geom point that you will usually not see the actual individual data points in a quality control graph. But if you actually want to see some widespread the actual individuals in the quality control setting, not just the means for each sample, each run, you can add that as a layer. Right? You can add a trend line to the whole thing. Right? I can just add a geom smooth, and I'll just use the default spline method. What's going on? That's not what it is. Oh, I didn't make the data. Let me go and make the data first. The slides and my thing here live in different namespaces, so. Now we've got the randomly generated data. I need to do library ggqc. I need to type library correctly. And we get, not only do we get the line connecting the means, we get a trend line around all of the different individual values as well. All right, let me give you a heads up. GGPLOT2 recently released an update deprecating several functions and options within it. Right? And so you're going to get warnings anytime you use StatQC. It's going to tell you the functions that it's built upon in GGPLOT2 no longer are supported. They want you to switch them. But you can't go in and change the code in, well, you could, but it would be a huge pain, in GGQC, so just ignore those errors. Right? I had to update my slides this past year as well because they didn't bother to tell anybody that they updated them. So I started getting errors in class on graphs that previously worked. Right? And so I'm giving you this as an example of something that you might use in your own classes, and there's a framework to make it super easy. And there are all sorts of different quality control graphs, process control, deviation checking, and stuff like that. There are all options for that in the QC framework. All right? All of these things are going to look super daunting to you, but I want you to realize that someone has done what you're trying to do before, and there's probably going to be a package for it. So don't beat yourself over the head trying to add 1,000 different layers to a ggplot command. See if you can't find online examples or packages that do exactly what you want to do, and use that instead. Right? So I've got some helpful resources for you here. We've got the ggplot cheat sheet that I've already given you. There are some nice tutorials in ggpub if you want just quick plots. And then finally, there's a documentation of ggqc. This is not the first Google search you get when you search ggqc. The first couple are not good examples because they do not actually have the code working in them. Someone screwed up on the documentation and the code doesn't actually run or show up. All right, and then finally, Google is your friend. If there's anything, if you ask me a question and I don't know the answer to it, I'm sure we can find the answer by Googling it. All right, so great. That is it for today. I'll open the floor up to questions now. We can spend anywhere from 10, 15 minutes, whatever, on anything you guys want to talk about in terms of plotting. How do I do this? What can I do for that? What options exist for this? And so on. I wanted to have some synthwave music playing in the background to go along with the sort of aesthetic slides, but I didn't want that to be a distraction. I guess I can put that on now. No questions? Oh, there we go. Oh, yeah, in fact, people get mad at me for how much I love Jupyter notebooks in Python. There's just one command you have to put in one of your first cells in Jupyter. It's been a while since I've used it on this machine. Let's see if I can't get that going. I should probably invest in an actual programming environment for my Python things as opposed to writing literally everything I do in Python in a notebook, but notebooks make sense to me. They're kind of like let's see if I can't find a I don't get on me for my file structure for these things. Sometimes I have it on my toolbar, so I'll accidentally click it sometimes, and they'll just pop up untitled ones. Well, let's look at the viscous term. Let's see what we got there. Oh yeah, 3D plots are useful for things like that, but I will typically just map it to a different aesthetic. So you're talking about, I kind of see what you're getting at now. I make animations in those cases. This does not look like, this is just LaTeX. All right, let's see what Final Project has in it. No, this is just a document. I've done some plotting in here. There's just a single, so is your question, Aaron, do you know how to do that? Because there's just one single command that's like inline plotting, like % inline, and that will give you that. All right, but to talk about what you're talking about, Hunter, I will make a GIF or a movie if I want to show change over time. Right? So I have in my Astrovisuals folder here, Astrovisuals, or I will look at some derived quantity changing over time, so that I don't have to worry about all my different aesthetics. So you can just make movies. Right. Well, yeah, I don't disagree with you about, you can have those sort of you can have those line plots that they change in time. I never felt the need to make one. I either include pictures as snapshots over time. I guess I can just fire up my dissertation if I can find it. Convection, or what is the name of that thing? Towards. I include just snapshots. I forget the name of my dissertation. But I just, here's the thing at 20 nanoseconds, here's the thing at 30 nanoseconds, here's the thing at 50 nanoseconds, and capture that behavior. And then, because we live in the future, you can link them to a website repository of your animations. which is sort of more and more research journals are giving you the option to do that. Yeah. Where you can give them a link to a page of your data sets, as well as any additional figures and animations on them. Yeah, exactly. I know when you're talking about the heat equation, I know exactly the plots you're sort of thinking of, where you've got, where do I want to do this at? You've got essentially, your axis, and then you've got the heat profile at time equals 1, time equal, and then, you see how this thing just sort of diffuses and whatnot. But you can put an animated GIF in a PDF, and I have done that. LaTeX will let you do an animated GIF in a PDF. It's interesting, and it does work, but not everybody likes or supports that. A journal will probably send you a mail bomb if you send them an animated GIF in a PDF. Besides, you get more grant money when you send them videos, because they can show that to their bosses, and everybody looks like they're doing something. Of course, it's not just about having videos. You have to know people as well. But between videos and knowing people, you've got yourself a funded grant right there. And like I was saying, if you're in Python and you want to do some three-dimensional visualization and plotting, MyAwi was the one I like. MyAwi was the one I played around with a little bit. MyAvi, it's one of those two. It's not MyAwi or MyAvi. 3D scientific visualization and in Python. And Mathematica is also nice for that, nice for these kind of things. You've got spherical harmonics or what have you, and they've got some nice little example codes here that you can get a thing. Let's see if we can't just make this work. I don't have that. Okay, I'll have to install it. But essentially, you can make your animations and stuff there. Mathematica is also a wonderful tool for that if you can understand the insane logic of the Wolfram language, right? Stephen Wolfram is kind of like the guy that was behind ggplot, the grammar of graphics, except he's trying to describe the universe using a paradigmic language in Mathematica. And so if you can be bothered to learn that, you can make some very good widgets and 3D visualizations in Mathematica. And the plots ain't half bad too. Right. That's your spherical harmonics are actually that's one of the use cases of that's one of the use cases for it, those orbital electron clouds. Think of these guys as three-dimensional Fourier transform, or Fourier functions, Fourier series. Right? Basis. It's a member of a basis. Right? You've got your regular harmonic functions, your sines and cosines, and you can use those to make an arbitrary continuous function as just a series of those harmonic functions. You can use these spherical harmonics to make you can do a truncated series of them to make other functions. It's not quite a 3D Fourier transform, but that's a good analogy. Any sort of 3D plotting is difficult. Like, even there's a video we've got here that our research group did of a supernova essentially detonating in 3 dimensions, and this looks nice and gives you some nice grant money, but actually determining on what the heck is going on is you know, not as easy. This is good for getting people's attention, but to actually understand what's happening, you're going to be taking line outs and slices and stuff of that. And so if you're working on massively parallel data from huge data, huge data sets on supercomputers, you're not going to be wanting to be in any of those things. You're going to be wanting to use something like visit or paraview, which is its own plotting, it's its own visualization routines. So when you're actually doing crash analysis of Visit is the single buggiest program I've ever used as well. So keep that in mind while you're working on it. I worked at that lab for a few years, and I had half the mind to go yell at the people for making such a buggy environment. Have I frozen? I believe I've frozen. All right, well, basically, you've got visit here. You got something. You just read the files in, and you add. It's similar to GGPLOT2, where you add your graphical elements, like a pseudo color of the density. Come on, I believe in you. I hate this program so much. But trying to get this data, because it's stored in a binary file format, into R or MATLAB is more trouble than it's worth, so we use visit. I think visit stands for visualize it, right? So they're about as good programmers as they are namers of things. How we doing, OBS? It says you're doing all right. Visit's crashing right now, so that's what it does. That's what it's for. Crashes. But if we were to get it to work, it would then depict a pseudo color plot, a density plot of. Let's see if I. No. Where's the window? Oh, there it is. Popped a window up. Quick draw. You can watch the time series evolution of some explosion that we did. And this was, I think this is a set of data that will let me look at my mesh refinement scheme. Mesh. They've changed it around a little bit. Let's see if that'll work. Yeah. So if you have huge amounts of data, you're going to want something like visit or paraview, which allows you to render the data in parallel. Like sometimes your data sets are on the size of gigabytes. R can't read that all into RAM. MATLAB can't read that all into RAM. It's just going to crash. So you need to use something that's a bit more, sophisticated and buggy. All right, so that's about it for today. I hope you all learned something at the very least. Please email me if you want the examples that I've included in the code. My talk. These just don't need to sit around somewhere in my folders. These are for you guys. So if you want these, let me know. You might set up some repository or something. Maybe I'll set up a GitHub so you guys have those. Or a website. I should make a website, but do you guys know anyone who makes websites? I know Fortran, not HTML. I'll just reach out to me on that. But that's it for today. And I'll just stick around. And if anyone has any questions, but if not, enjoy your weekend. All right, remember to like and subscribe. Smash that bell if you want updates. You know, follow us on Patreon at, if you can't, those who can do, those who can't learn, Dr. Learn. Yeah, whatever you want to do with it. Next week, we'll be talking about the basics of advanced mathematics, basic advanced math. And that's exciting because you need to be able to read the definition of a limit sometimes. Right? You're all engineers. You know calculus. Oh, yeah? Well, explain what the heck this thing is saying. I didn't want to click on that one. Why is Wikipedia on the top? We just need to save this somewhere. If you like calculus, tell me what that says. Yeah, that's what I thought. So we're going to talk about, essentially, what all these symbols mean next time. And you guys, you don't really need to know that 95% of the time as an engineer, but it's nice to not be intimidated if someone were to flash that on the screen, and you could actually know you could parse it if you just took the time. Yeah, that's fine. You know, we're all busy, so we'll just iterate, and eventually this will look nice. You'll be like the CFO of Boeing by then or something. But whatever. My students are just going absolutely nuts.